Hi guys, my name is Benedek. I'm a professional software engineer dealing mainly with Unity and C# development. In today's video I would like to show you how to create this simple clicker game in Unity. Here you can see that whenever I click that ball, many foods are just shooting out of it and our score is increased. Alright, let's get into it. Alright guys, I'm in Unity. I have created an empty project for this called Clicker Game Demo. Note that I'm using Unity 2021.3.9 F1. So if you wanna follow along, maybe you shall use this version also. But of course you can try with other versions as well. Alright, so first step, I will just rename this scene to main scene from sample scene. Now I will create a simple sprite, a square. It will be our player actually. So this is the point we want to click and that will increase our score, Alright, we have created it. We need to assign it a collider. I will go with a box collider and the box collider 2D specifically. Okay, now I will need to create a script to handle the clicking of it. So I will create first of all a folder for the scripts called scripts folder, and here I am going to create a new C# script called let's say player controller, but you can call it anything else if you wish. I open it in Visual Studio. Here we go, it's loaded. For now I will get rid of these methods which were pre-created for us. I will define an integer score variable that will be the number of the clicks, and we will increase that each time the player is pressed, and we will use something called TM Pro Text Mesh Pro UGUI. It will be a text actually, which we will be creating just within a sec on the scene. It will be the score counter text, so that we will have that display. And here we go. On the scene, on the hierarchy view, I am creating a UI text mesh pro, and I have to import the TMP essentials for this. Okay, it is imported. Now here we go, we got a wonderful text here. I will rename it by pressing F2 on it, or just simply right click and rename. I will call it score counter text, and I will click this one and hold down the shift key and press this button so that I am aligning it to the top left corner, and I'm zeroing out the position. I am adding a little bit of a margin to it, and I will say something like score 0 at the beginning. Now I need a reference for my script. First I need to assign the player controller to the player, so I will be drag and dropping it to the player. And as you can see, there is a reference for the score counter text, and currently none is assigned to it, so I will drag and drop the score counter text to there, so that we can modify the displayed value based on the clicks. Okay, we will use a Unity method called onMouseDown, and it can be used whenever our game object is pressed. That will be fired, but you have to remember that you can only use the onMouseDown if your game object has a collider. If it has no colliders, that won't work. Okay, so I will use the onMouseDown, and here I am going to create a new method called onPlayerClicked, and it will be a custom method. That is not necessary, but I like to structure things. Alright, and here I will do simple stuff. I will increment the score variable by 1. This is how I can do that. And I will update the text displayed there. Now that I can update the text via referencing the text mesh pro object, and its text property is the string or the text which I can actually modify. So I am assigning the score values string to it, and I'm telling that it is a score. And now it should work as expected, so I'm going to test it out real quick. Alright, as you can see, now it is already working. Okay, let's make it a bit more fun by bringing in the images and the foods. Okay, so I will bring in the sprites, or with another word, the images. Alright, I found a nice picture of a bowl on the internet. You can use it. I will put it in the description of the video so you can use the very same asset. I am selecting the player on the scene, and I will drag and drop this bowl to the sprite field of the sprite renderer of the player. Now we need to get a different color for the background, I think. So I'm selecting the main camera, and I am assigning a new color to the background. I think it's a good color. Alright. Okay, now we need to make it more interactive. I would like to have this bowl becoming a little bit bigger whenever I press it. So it is kind of an animation. Now I could use here Unity Animator and Unity Animations, but I will do it more easily via code. I will modify the local scale of it. If we hit the player, you can see I'm just demonstrating what I will do via code. The scale currently is 1, 1, and 1. But I will be increasing that programmatically, let's say to 1.2 and 1.2, so it will be a little bit bigger, and then I will wait a little bit and downscale it again to 1, so that we will have that tap effect, let's say. Okay, so I go to code now, and I will create that effect. I will create a simple enumerator for this one. Let's create it at the end of the code. An enumerator is basically a coroutine, and it is a way to define waits and asynchronous operations. So it is used for asynchronous parallel executed code. Okay, so I will call it play tap effect, let's say. And now what I am going to do, I will create two variables for this. That will be, the first one will be vector free original scale, and this will be the original scale of the game object, which is just 1, you know, just as I've showed you on the inspector panel. And it will be the tapped scale, so that will be the increased scale. As we discussed, it will be 1.2, and here it says that it is not a double, but it is expecting me a float, so I have to put in an f after it. Because it's a floating point number, and it requires me to use a float. Okay, so the idea is that I will use the game object's local transform, and I will change it to the tabbed one, so the bigger one. I will wait for, let's say, the 1/4 of a second, and then I will scale it back downwards. Alright, let's do it. So I will grab the transform's local scale, meaning that the scale of this game object, and I will assign it the tapped scale. Then I will wait for the 1/4 of a second. So this is how you can do a wait in Unity. You can, inside an enumerator, you can yield return new wait for seconds real time. and with this method you have to pass in a number of seconds you want to wait. Here I want to wait for the fourth of a second, and after that I will just assign back the original scale of that game object. Now I would like to happen, so I would like this effect to happen only obviously when the player is clicked, and this is how we can call it. So we have to use the start coroutine because it is a coroutine, meaning that an enumerator, and this is how you can call it. Alright, let's test it out real quick. Yes, as you can see now, it is working as expected, so we have that little tap effect now on the bool. How cool is that? Alright, now let's bring in the fruits. For having fruits and foods in our little game, we will use this free to use Unity Asset Store package. You have to be, logged into Unity, and then you can download it, and after you downloaded it, you can open it in the Unity editor. And now I've already downloaded it, so I have to import it to my project. I hit import, and it can take for some minutes. Yeah, it's already imported in my case. Here it is. This folder is for that one. I go to the art, and here, as you can see, we get sprite atlases, and under the icons, if we click this little arrow, you can see that there are those pieces of food and fruit and veggies which we will use for this kind of effect. So first of all, I am going to create an empty game object, and I will call it Food Factory. And under the Food Factory, I will assign pieces of food which I like. I like this one, for example, but it is obviously too huge, so I am going to alter its scale a little bit. Let's say I want to have it 0.05 or 0.06. Alright, and maybe it is here, but under this bowel. So if you cannot see it, you can try to deal with the z of it. Maybe it is just the z-axis. Yeah, as you can see, I had to alter the z-axis of the Food Factory and the donut as well, and now it is visible again. Okay, so I will bring in more pieces of food. I'm gonna just copy the position or just the whole component. So I go to the other one, the transform, say copy component, and I just select the other one and say something like paste component values. Oops. Paste component values. Yeah, here we go. So basically what we did is just copied the settings for this one as well. Okay, I will bring in more foods. Probably I will just fast forward it so that it won't be too boring for you guys. Alright guys, I've just created all of these food here, and I've just altered the scale of them so that I've just played with it how it looks cool, nothing much fancy. Now I want this Food Factory to be a prefab. A prefab is just a prefabricated object so that I can instantiate multiple instances of them. So I create a prefabs folder under assets, and I am just going to dragging and dropping this, and now I can delete it from there. Here is the prefab of this, and the thing is that you can drag and drop multiple elements of it. So this is the point. You can instantiate multiple instances of them, and you can even instantiate and move them via code, and that is what we are going to achieve now. So I am selecting the player here, and here in the player controller I will create a new variable which will let me assign this to the player controller. So I open it and I will go here and say public game object, and I will call it food factory, just like we called the prefab as well. Here is our new variable, so I can just go and drag and drop it there. There we go. We have now a reference for this prefabricated object or prefab, from which we can choose multiple food types. Alright, so how we do it? First, we would like to iterate through each of these elements. So elements of this food factory. So I mean the children of it. So over these we would like to go through each of them, and we want to have them being spawned there, and we would like to project it out, so shoot it out in a direction. Let it be left and up, or right and up, or just forward upwards. So we will assign it an X kind of move direction randomly. Let it be left or right, and it will get an upper random movement vector, and then we will assign that to them. So enough talking, let's do it. Okay, the thing is that before I go through it, I think it's even better to already define that function in which I would like to just create these random positions. So what I'm going to now do is I'm creating a new public vector3 function. Vector3 will be the movement vector, let's say. So get random movement direction vector. That is where we would like to shoot out our food. So I will define a whole number, so an integer number, for the x modifier. So the direction x modifier will be a random number between -4 or -1 if we want to go left, and if we want to go right, we will use a random number between 1 and 4. So but I would like to generate it even on a random, so I will use random.range, and I will create a random variable, so a random number between 0 and 10, and this is inclusive, so 0 and 10 can be the random number, and anything between those. So I will say if the random number which we got here is bigger than 5, then I want this to go in a direction of left. So how do I do that? I will use random range, and I will use -4 and -1. I will explain it why I am doing it. Oh yeah, and I have to put in a question mark, so meaning that if this condition is true, then I want this to be the x modifier. In case it's not true, then I will have the random range between +1 and 4. Okay, I will explain why, how these numbers are coming. Okay, I will show it real quick. Let's show it with the player. If I select the player, as you can see, its positions x is when I move it there. So in the negative area, if I go anything beyond minus 8.7, it will be going out of the screen. And I don't want the food and vegetables to be on the very edge of the screen. So I want them to go out left at a maximum of -4 direction, and also this is the +4, so when it is right, then that will be the angle in which the veggies will be coming. And yeah, that is it. That's why I am putting in those numbers, and this is just because we had to do some kind of decision. Now I will create a vector from this. So I will return an up vector, which I will modify in a way that I will put in the direction x modifier as the x, 4 as the upper direction, and 0 for the z axis, because it is a 2D game. And this will give us a good way of shooting out our food, upwards and towards left or right in a normal angle, let's say. Okay, and we need to do this to every every food, but these food instances are not in the scene, but they are inside a prefab, and especially in the prefab they are children game objects. So I will have to iterate through the food factory. We will be doing it here in the onPlayerCreate function, but I will create a new method for it called FoodRain, because that's a good name, I think, for this. And here I will create a new function for it, public void FoodRain. And the FoodRain, I will instantiate the food factory, so that it will be in the scene, in the game. So game object food factory, and I'm instantiating that prefab. So I'm creating a real instance of that prefabricated object, and it is already there. And I will put it to the transform, so under this object. And now I will go through each element of the food factory game object. So I will use a for loop for this, and I will go through the children of it. So I am selecting the transform, and I will say something like I will go until we reach the end of the child count. So this is how I can go through one by one on the elements which are present in the food factory. So if I want to go through each of them one by one, that's the way I can do it. Okay, now I will make sure that they are perfectly aligned with our bowl, with our with the center of our game, so that I will modify a little bit the position of the current food. This is how I can get the current food. So I use the I, which is the control variable in the for loop, and I get that child, and I get that game object, and I set the transform position of that game object to this transform dot position, so that it will be perfectly aligned with the bowl. Okay, now I would like to move it, and I would like to have it a movement direction vector. But it is not so easy, because first I would like to so I would like each and every fruit to have one particular movement direction for them, so that I will create a collection which will contain the game objects, the fruits and foods, and their movement vector as well. So that will be a public dictionary, and that will consist of a game object, and that will consist of a vector free. I will call them foods and movement vectors. So this will be the food objects and their specific movement vectors, the direction which they in which they should be, projected out. Okay, so I am creating that one, and here I will put this particular instance, so the game object food factory that transform the get child I, so the specific food there, and especially its game object. And now I should put in there a vector free. It says it to me. So I will put in the. So I will get a random movement direction vector with my function we just created here. So this is how we can put in the specific food and its very own unique randomized movement direction vector in which it should be projected out. Okay, so now I will use a fixed update loop of Unity, which is just a frame rate independent version of the well-known update function, and it is more beneficial for physical movements and calculations. So what I am going to do now is I am going to iterate through the keys of this collection. The keys are just the first elements which are present there. Note that as this collection is consisting of game objects and vector frees, so basically the foods and their movement vectors, the keys will be the game objects, so the food elements. So basically what I want now is just use a for each loop, and I am going to iterate through these dictionaries keys, so the food elements. And if the current food element is null, meaning that it has been deleted, in that case we are just going to remove it from the collection. So from this one we will remove the item which is registered under this key, so meaning that we won't keep track of the direction vector nor the game object. And now we need to break out of this iteration, obviously, because we are inside this very loop which is using the very same collection from which we are deleting, which is not a good idea which would not be a good idea if we wouldn't break out from it after doing so. Alright, now I will actually manage the movement. So after the pieces of food are just instantiated, we want them to be projected out upwards and to one of the directions, let it be left or right on the randomized direction vector. But we only need to do that if the food is inside the boundaries of this screen, and not just that in the screen, but it is in the kind of the center of the scene. So to achieve this check, I found that this kind of conditions are good way to achieve that. So I am basically now testing if the current food is not already beyond the edges of the screen, and if it is reasonably in the center of it, meaning that I am testing if it is not above 4.7, because if it would be higher, than that. I don't want to elevate it more, and if I am checking if it is not already in the very left edge or on the very right edge of the screen, because if so, I don't wanna move it more to that edge. But if it is not the case, so it is here inside the kind of the center of the screen, or the center area, then I want to grab the transform of that food, and I wanna translate it, meaning that I wanna move that, and the amount and the direction of the movement is defined by the corresponding value for that food key in the foods and movement vectors. So I am now getting the movement vector from here, and I am just multiplying it with fixed delta time to make it smooth, and I'm just applying a little bit of a multiplication by 6 so that it gets a little bit more momentum. Now I will also do something which is very important. If those pieces of foods are outside the boundaries of our screen, then we would like to erase them so that our CPU is no longer keeping track of it, meaning that I will test if the position y component, so the height of it, is less than or equal to -6, which is the very bottom edge of my screen. In that case, I would like to destroy the food game object, so the current food, so that food which is already not visible, and I would like to break out of it so that again I don't cause any issue with doing so. I mean with deleting that inside of an iteration. So that's how we can implement that one. But we don't just need to delete those food instances, but also we need to delete the food factories. For having this so for having those deleted, we need to create a way to keep track of them. So I am now creating a list of game objects, and I am saying food factories, and I will create it as a new list of game objects. And whenever a new food factory is created, I would like to assign it and add it to this, and here we go. In the food train, here is where we instantiate it. So I will just add it. So add the newly created food factories to this list, so that I will check if a list, so if a food factory has no longer food inside them, I mean it has no longer new children, I would like to delete those instances as well. Okay, but I think I should do it outside of here. So I will create a new method or new function for this. I will call it check and delete empty factories. And what I want to do is I will create a new game object reference. I will call it factory to delete, and it will be null by initial, and I will go through the collection I've just created and to which we already added each our food factories. So I am iterating through the food factories, and I will check if that factory game object, and especially its transform, so I will check if it has no longer children. So if the child count is 0, that means that food factory has no more remaining foods. So all of those foods which were spawned by this factory are now invisible and are deleted. So we don't need to keep track of that food factory anymore. So what I will do is just I will use this variable and I will put in the factory, and I will remove from the food factories this current factory, and not to cause any issue, I will break out of this loop after that, and here I will just check if the food factory to delete is not null, meaning that it has been assigned a value to it. Then I will delete whatever has been assigned to it. And this is how I can get rid of already emptied food factories. Okay, and now I will call it here because it makes sense, and also I will probably call it in the very beginning of a fixed update iteration. So on every frame I will check if there are some already emptied food factories which has to be deleted, and if so there will be deleted. And also if I delete a food instance, I will then also check if its factory has already been emptied or not, and if it is needed I will also delete. Now just one addition, guys, I probably haven't mentioned to you, but it is very important. In order to have them falling down, I mean those food instances, I went to the prefab instance, I opened it, and I I selected one of them, I hold down this shift key, and I selected all of them, and I added the rigid body 2D component to it. And the configuration of them should be exactly the same. It is very important, because if you don't do that, basic gravity won't be applied to it. So if I am removing those components and saving that, you will see that those newly created and projected out fruits and foods are just staying there forever. So to tackle this issue, you will have to just assign a rigid body 2D component to all of them, save, and as you can see now it will work as we wanted it. So this is the way to go. Alright, I hope you liked it, and if so, please consider subscribing to my channel not to miss any of my videos. Have an absolutely wonderful day wherever you are. Be safe out there. Bye.